Welcome to qnawire.
In this problem, you're asked to determine at what height above the center of a billiard ball should it be struck horizontally for rolling without slipping to occur. So here's a sketch of the problem. The billiard ball with a center G and radius R is initially at rest. So therefore, its velocity is 0 and it has no angular momentum. So I omega 1 is 0. So it will be struck horizontally by the Q stick with a force F at a distance h above the center. So we have it here in the second part or at the middle, and then this force will cause the ball to start rolling without slipping with the point C as the instantaneous center of rotation. So we have it here at the last part of our diagram. So to solve this problem, we will apply the relationship between the torque experienced by the billiard ball and its angular momentum. And this is given by the equation summation torque equals the change in momentum or the rate in the change in momentum. So change in momentum over the time interval. So substituting the equation for torque and angular momentum, this equation becomes, so as we know, torque is force times the lever arm. So in our case, that would be FH, then equals, so the change in angular momentum, which is, so I omega 2 minus I omega 1 over delta t. And as we know, since the ball is initially at rest, so this becomes 0. Hence, our equation becomes, so FH equals I omega 2 over delta t. Then solving for h, we'll have, so h equals I omega 2 over f times the time interval. F times delta t here is equal to impulse. So which by the principle or by the impulse momentum theorem, we know is equal to the change in momentum. Hence, our equation becomes, so H equals I omega 2 over change in momentum. So, substituting the equation for momentum for the denominator, so we'll have H equals I omega 2 over, so final momentum mv2 minus mv1. And again, since the billiard ball is initially at rest, so this is 0. So our equation for H would be, so H equals I omega 2 over m v sub 2 or v2. I here is the moment of inertia, and since the billiard ball is a solid sphere, its moment of inertia is equal to 2 over 5 mass times the square of the radius. And as we know, omega here is equal to the velocity at point C over the radius. And since the billiard ball is supposed to roll without slipping, so V is equal to the velocity at point C. So substituting this in our equation, so the equation for H now becomes, so H equals 2 over 5 mass times square of the radius, and then omega is BC over R, okay, all over M times VC. So the mass will cancel out, VC also will cancel out, and then we'll have R here. So our H, or H, is equal to 2 over 5 times R. So the billiard ball has to be struck at a distance equal to 2/5 of the radius above the center for it to start rolling without slipping.